Okay, so you were instructed on this worksheet to take a look at Ray Diagrams Video 1, which is what this is. So first thing we want to do is, as we're looking at this worksheet, we want to make sure that you got the answers right. Okay, so it says an object is held in front of a concave mirror. The image that you see of the object when you look in the mirror is inverted and smaller than the actual object and can be projected onto a piece of paper when the paper is placed at the location where the light rays that have reflected off the mirror meet. In order to produce this image, would the object be placed close to or far from the mirror, relatively speaking? All right, well, looking back at our sheet, what we should see with this is that you're going to place that close to, or sorry, what am I saying? You're going to place that far away from. I was momentarily distracted because I hadn't touched the screen yet, but the pen was still drawing on there. So far away, at about an arm's length away. If you're holding the lenses, or sorry, the mirrors that we have in class about an arm's length away from you, the image you see in there is going to be upside down and it's going to be smaller. Is the image real or virtual? Hopefully you said it's going to be real, and it's going to be real for two reasons. One, you could project that image onto a screen, which is what they tell you in the description, and two, it's inverted. Those two things make it so that it's a real image. Okay, so 3 says watch video number 1 on drawing ray diagrams on our class website. That's what this is. That's what this video actually is. So let's take a look at that and see what we got. What I'm going to do with this thing first is try to draw a mirror. They said it was a concave mirror, so I'm going to draw a mirror that is concave like this. Okay. That's my concave mirror. And then things that are important for us to note. We need to know where the, that pen's acting funny. We need to know where the object is located. Well, you held this thing far away. By far away, what we mean is significantly farther away than the focus. I'm going to say even more than 2 focal lengths away from this mirror. So if we say that we're using a mirror that has a focal length of f is equal to 10 centimeters, which is what we'll be using a lot in class, then 2 focal lengths away is going to be about 20 centimeters, and that's also equal to the center of curvature, because the center of curvature is always twice the focal length. Okay, well, if we're using something like that, then what we want to do on our ray diagrams is draw these things as much to scale as we can. So to do that, let's go ahead and say, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these blocks. Let's say that 1 block is equal to 2 centimeters. Okay, so then I'm going to put where f and where 2f are. So 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, 5. 5 2-centimeter chunks would be 10 centimeters. And then 1, 2, 3, 4, 5. That's 2 focal lengths away. And what I was saying is that the image is upside down and smaller, then that object is going to be placed far away from the mirror. Well, far away means more than 2 focal lengths away. Okay, for our object, in general in this class, we're going to use either an arrow or I like to draw a candle because we're going to be doing a candle lab in this class very soon. So that's what we're going to be looking at. All right, that candle, we know, actually puts light rays out in lots and lots of different directions, all over the place. Okay, these are light rays, apparently purple light rays coming from the candle in all different directions. We could trace any light rays we want, but the light rays we're actually going to trace are light rays that we can predict exactly where they're going to go. Okay, so there are just certain light rays that make more sense to follow. The first one I'm going to follow is a light ray that comes in parallel to this line, where this line right through the center of the mirror, right through the axis of the mirror, this line is called the principal axis. I want to trace a light ray that comes in from the candle and comes in parallel to the principal axis. And when you're drawing these diagrams, they only really are useful if you draw them to scale and if you draw them so that, with a ruler or with a straight edge. So I have my straight line drawer on here. You should be doing these with a ruler. All right, so my light ray comes in, the incident ray comes in parallel to the principal axis. Where do those light rays reflect out? Well, in class, or hopefully in class, and if not in class yet, in class when I come back, you're going to have light rays that come in, and anytime they come in parallel to the principal axis, they're going to reflect off and go right back through the focus. Okay, so that light ray that I've got drawn in blue. And some of you might find that drawing them in different colors is also helpful. Helps you keep track which light rays go together. That light ray is going to hit the mirror and reflect through the focus. Okay, well, that doesn't tell us where light rays are going to converge to, but it does give us an idea that, hey, the light comes in, hits, and bounces through there. All right, the second light ray I'm going to trace, I'm going to do sort of the same thing, only in the opposite way. So I'm going to send in a light ray through the focus. Okay, that light ray is going to hit the mirror, and let's kind of play this through in our minds. That was a terrible arrow. If light came in parallel and reflects out through the focus, light that comes in through the focus, based on the law of reflection, should bounce out, and it's going to bounce back out parallel to the principal axis. So do your best to make that look parallel. Okay, mine looks roughly parallel. All right, so I've got that light ray reflecting back out parallel. Well, where those two light rays meet, because if I'm looking at that blue light ray and that red light ray, they do converge. They do meet someplace. They meet right here. If you took, that was my object, if you took a piece of paper and you put it right there, what you would find is that the image of that candle would come out perfectly clear here. You'd be able to see exactly what's going on. The details would be fantastic. Out here, you'd have light hitting the candle or the piece of paper, but it wouldn't be clear. In here, you'd have light hitting the candle, but it wouldn't be clear. But as you got closer and closer, it would come into focus, and right here, you'd get a focused image. So right here, I'm going to draw from the principal axis headed downward. This is a candle. That's my image. And that image looks inverted. Okay. It's real because the light rays actually meet there. And if I'm looking at it, if I was looking at the heights, it's kind of hard to tell on my picture, but this height looks a little bit bigger than that height. Okay. And that is true. This height is bigger than that height. So my image is also smaller than object. And if I was looking at where that object is located, it's located between F and 2F, in between F and 2F away from the mirror. All right, that's our first ray diagram. What that does is it shows what the light is doing to create the image that you see. So if your eye is out here, okay, what your eye, those are eyes, what those eyes would see would be that if they look right at this spot, they're going to see an image that is in focus and clear. If you put a piece of paper here, you will see a clearly focused image. All right, that's how you do ray diagrams.